Hello and welcome back, everybody. How is going, chat? So today, as usual, we are going to continue our adventures in Rust land, our super interesting adventures. And I'll a little bit describe my work, what I did like today for the RoadRunner in Go. So basically, the whole my day I am working on the documentation. So we have this like staging. You can like get this address, but yeah, this is kind of official address. And here's how we look our future docs for the RoadRunner. I'll shrink a little bit these integrations for sure. Like I'll remove this old, I don't know what is slim. Is it popular or is it dead? Maybe, I don't know. So Falcon, so yeah, as well I don't know what is a Falcon. Let me check, by the way, what is it? Whoa. So it's in Chinese. Best practices. Yeah, it's kind of alive. Yeah, so I'm going to shrink a little bit all this integrations, as you may see here. So today I have almost perfect like combination of all of these articles here. So for example, we have now about RoadRunner refreshed page. We have like a features, updated features. So I don't think someone spend a lot of time being on this category. So because it's like link, yeah. The most interested categories here is, I guess, PHP workers. This is about how it works, basically regarding to the RoadRunner 2 and Run 2023. Updated debugging section, so updated developer mode, how to use, like, for example, stop command, and etc. So we also, as you may see here, we have this nice looking warnings here. We also have a dark theme here, but it kind of, I don't know why it's working like this. If I update page, it will like reset this. So this is definitely a bug. It will be fixed by our front-end team, and we also would have a nice feature. So as a part to pass a remote, a RPC, and a relay to the worker. So every worker have these 3 environment variables by default on like any pool. And we also would have a reversion, and started from 2023.1, RoadRunner will provide this environment variable, and worker will know what version is currently running with this process. And you can like behave differently depending on the version and the features included in this version. Yeah, so also we have a new updated section. So I split plugins section because it's kind of overbloated section with a lot of like plugins included in it. So it's like a long list with a lot of names. For example, what does it mean memcached? So what is related to what subsystem? So memcached, okay, so it's key value driver, so it's obvious. But for example, BoldDB, so we have BoldDB here and BoldDB here. So if it like plugin BoldDB, what purpose solves this plugin like BoldDB? So it's like key value or queue, or what is it? And now we have this nice looking split section. For example, like production usage. Oh, it's like resets one more time. So we have a like section with useful tips. I like grab every discussion. I try to like extract some kind of point of knowledge here to add and to aggregate everything related to tips, like so which can help you to run RoadRunner in production. And also we have this, so plugins here mostly related to some plugins which I can't put in any section. For example, centrifuge. So this is hard to address a section for this plugin because this is kind of WebSocket broadcast system, and we have only one such plugin, and yeah, this is hard to, you know, somehow combine like a set of plugins and create a section for it. But I'm also thinking about how to, if we would have a lot of things related to gRPC, for example, so it would be nice to also have a separate section, so like servers plugin also. So this documentation will be related only for the RoadRunner and the Go application. So this is not a PHP documentation for sure, but we have, for example, in key value, oh my god, once more time. In key value section, for example, we have small like PHP injections here into the documentation, mostly about how it works actually. So but for the full documentation, you can always refer to the like, where is it, where are you, little documentation. Yeah, I need to, I guess, so everything except the actual worker. Yeah, so I need to, I guess it should be RoadRunner EV. Yeah, so I need to add a reference to this RoadRunner KV. Okay, so, and also like separate section for the queues. This is for our jobs plugin. I don't know why it's called jobs. Might be some common name in PHP world. I actually don't know, because in my world this is a queue. So definitely I never call queues jobs. So I think this name comes from, I don't know, Laravel might be, or some other framework, but I don't know actually. So but this is like a common name for the spiral, and that because we use this jobs queue plugin. Yeah. And here we have, oh my god, here we have like splitted sections per every job or queue driver here. So in previous iteration, as you may see here, in the RoadRunner dev, like our first version, second version of the documentation, you have like this. So a long list of like of the sections, like you have to like go here, and if you scroll a little bit harder, so I'm on the beanstalk section, hoppa, like this. New sections, and I split all of these plugins. You have here information related only for the like AMQP or RabbitMQ especially. And also I have these nice things, what features introduced in what version, what run version here. So for example, you may track if you have like some outdated run version, you may like see if you have a problem. For example, you don't have a queue headers, you like arguing where's my queue headers. So, and you are on the 2.7 or any version actually up to 2.12, you can like find the documentation and like, oh yeah. So they added this in version 2.12.2. Yeah, and also beanstalk, yeah, and everything like related to the queues and jobs. And also nice section HTTP. So HTTP now combines everything related to the HTTP middleware, so a file server, so everything regarding HTTP stack actually. And one of my favorites I'm sorry, sections is customization. So how you can customize and how you can build RoadRunner with your actual plugins. So how you can like write a plugin and how you can connect it to the actual RoadRunner ecosystem, and etc. So I'll remember that, I'm sorry, that plugin is like separate piece of software which can be absolutely independent from the RoadRunner. So you can depend only on your custom packages. You can have it on private account, like private Discord account, for example. And so Velox tool, which builds all of these things together, also can build this for you if you use a private account. So we are not limiting here to only public. So you have to have all the plugins in public, so everyone will see you Amazon keys in your private repository, you know. So and this I also revisit all of this section and rewrite mostly like all of the parts, updated to the most recent RoadRunner version. And I'll try to build, so the next step for me is try to build plugin with this tutorial and also improve it slightly or significantly. Yeah, so this is basically how to build a plugin, how to build a custom middleware. Also we have a video. I'll also actualize these videos. We have yeah, how to build RoadRunner actually with a custom plugin. So I wrote videos for this. So now we have, I don't know guys, now we have like a slightly better documentation that we had previously. But previously we had a trash docs actually. So now also important part of this update that we have documentation in the RoadRunner server organization. And if you want to, like, if you see an error, typo, etc., especially during the Hacktoberfest and you want to get a t-shirt, so you can I'll include this repository into Hacktoberfest, and you can like make a 3 pull requests, fix a typo, and get your t-shirt, you know. Marketing. Yeah, so yeah, this is what I did on my actual day, and what we're going to do today. Now let me just answer on open the Twitch on my phone to see your messages. Okay, so what we're going to do today. Let me close this. I don't want this one. Rust Playground. Yeah, we might need this. And let open Goland on the like right part. Oh, this is RoadRunner. So I'm trying to find SDK. Where is this SDK? But looking at the RoadRunner repository actually. Yeah, here you are. We don't need your RoadRunner, unfortunately. And so yesterday we stopped our work on figuring out a very important thing about borrow checker, that we can basically do the following. If we take the option out of child, then we would be able to use the child as a separate process, like we did, for example, in the Gorage package here. So actually what we did here, so we started a thread, move all of this, which is like here, to this inside of this thread. We allocate a buffer here, and which is more important, buffer actually holds a child. Our child is stdout actually. And which is more important, as you may see here, if we will use as mute, so we get a mutable reference, which is important, mutable reference to the std out, and std out will still be in the child. So in this case, we'll get an error. Buried data escapes outside of associated function. And if we try to build cargo please. So you may see here that second mutable borrows occurs here, first one here, and self actually escapes, and yeah, and here is mute self, and self is represented by our child here. So like basically everything escaped to like everything. But if we use take, what the documentation says. So if we use take, as you may see here in this sample, we have some 2, so we have an option with a 2. If we use take, then ownership of this like value will be y, like here, and x in this example would be none. And this is very important because in this case we will be able to use x and y in 2 different threads. And what is the error? Why is the error? I moved back everything. Oh, no. Take. Here we can use as immutable, but here we can't use as immutable. We should use take. Yeah. And what is important thing here? Since we taking child out, taking std out of child, our problem is how we return it back. Because when we receive std out, yeah, so we receive some data from std out, obviously we will need to receive not only one time, so we should receive like continuously for a long time period. So while worker working, so while this during this period we have to like receive the data from it. But if we like take this std out, it on the next iteration it will be none. And for us it's very important, if we are not, so if we are killing it here, it's actually doesn't matter. So this is a dead child, I'm sorry, but this is dead process, and it obviously this process doesn't have anything related to std out, std in, or std error, so everything is dead. But in case, for example, if we verify our CRC on this 112 line of code, we definitely have to return it back, especially here. And how we can do this? Let me just try one approach. So let me self child std out is some, like some std out. Can we do like this? No. Use of moved value. Let me see. So basically is a problem here, how we can return it. Oh, expected like this. Value used after partial move. Oh, some child here. So I guess we can return it only out of this sum. Tutorial. So I do like these error codes. They are awesome actually. So you can figure out what's happening actually very quickly. Do we have a clone? No, we don't have it. Rust return Rust return to the sender. Rust return option after take. Yeah, so option, yeah. I guess our problem here is yeah, so this child. Oh, might be we can use like this. Option enum. Std is and yeah is option from well moved here. Oh, so we have to buff. Yeah. So now at this moment, this is a very tricky part, you know. So at the moment, our child is inside the buffer, and we can't use it directly here. We have to extract it from the buffer. We can't get mutable. We can get reference into inner. Can we do like this? Oh, yeah, we can. Nice. So this is how we are going to. This is how we're going to return this option. Actually, guys, I don't know if this is a Rust way to do things like this, to like get something and return it back, but we have to do this. So if we just take the value out from the std out, we won't be able to, you know, I'm sorry, to use it on a second iteration, and I can prove this. Let me use like this, like to receive std out, you know, and let me comment out this return operations, you know. And let's run it. I don't know why it's like builds from the beginning every time. So first iteration, like okay, verify CRC, we don't need this. And the second one, std out should be none. Yeah, as you can see here, it's none. So we just can't take it 2 times. We have to return it back. And with this simple operation, we are going to return it back. And let's try once more time. Yeah, first sum. And second one, still none. Okay, guys. Houston, we have a problem. So still none. Why? We missed something? Oh, yeah. So this is because we use this error. So we basically we killed the worker on the previous iteration, and it returns us none. So let's try again from the beginning. So what happened? I just get into this if, where we doesn't return this value actually, because here, as I said before, we just don't care about this. Hello, Yoma. Take something and give back. Yeah, definitely. So about borrowing, so you can't just borrow everything and like then you have everything inside your pockets. You have to give something back. This is so true. Like, okay, we started jokes about the Rust, and actually I don't know if this you know, if some super professional Rust developer says this, okay man, you're doing something wrong, so we have to revisit how to do this actual, but we will learn how to do this Rust way. Might be this is a Rust way, I don't know actually. So I just figured out how to make it working. Okay, let's try one more time and return. So yeah, so we have some, fine, and the second one still none. Oh yeah, none, because yeah, we have nothing here. We did like exactly what Yoma said, like we borrow everything and doesn't return nothing, and return nothing. Yeah, so some okay and some okay, nice. So now it works like expected. None std out. Possible worker, possible dead worker usage, like this. So super clever error message. Okay, so we are killing the worker here. Okay, fine, we return this back. I don't know how much this cost for the performance actually, because in Go we don't need to do this. We just have two mutable references to the same object and like, okay, it's fine. But in Rust you have to return, and I don't know how to does it cost something to like do things like this, or option from? I don't need, maybe I need just to do like this. I don't need option from. Okay, nice. And what we're going to do now with this knowledge, we basically can't have let me show what we can have to have error note. So this is time to write from the right. So we can't have the architecture like this. So if we would have like thread 1, we take for example std in inside this thread 1, and we would have, for example, thread 2. We would have let's say std out here. So which we can, like, here we send the data, from this we receive the data. We just can't do this asynchronously, because we always should fit the std in with I'm sorry, std in send with std out receive. We can basically write some kind of synchronous mechanism, like for example, have some shared map here, which would have access to both std in and std out, and if we write, for example, if we wrote with id 1, we would expect id 2 here, or id 1 here, so to be on par, for example, id with id, like to match. So we can do mechanisms like this, but I don't think this is very important to actually to do, because we might send very quickly and PHP might be slow to respond, and anyway we just create a big line of the requests here. So I don't think that would make any benefit to our application, but it's definitely overcomplicate all this thing, and this because we have to do this synchronously, like at least at the moment. So at least at the in the POC, just to see that everything is working correctly, at least, you know, and then we can start experimenting in like asynchronous things, and you know, add features and whatever we want. But at this moment, we're going to do just simple synchronous operations like send, then receive, and like send, receive, send, receive, send, receive. Basically, PHP is kind of slow, and so if we would have, for example, Rust inside this process, I would say that okay, might be that would have some benefits to have an asynchronous system, because Rust can send and receive very quickly, being inside this process. But while in our process located PHP, like after send, we can wait up to, I don't know, like 100 milliseconds. You know, 100 milliseconds for Rust. It's like entire universe. It's like 10 years for Rust. Yeah. Okay. So since we are done with this send and receive, at the moment they are synchronous, now we can get to our actual exec function. And I remember what was our problem. Our problem was actually in this script. We should have this script blocked until, so in a different thread, blocked until we working with std in and std out. You know, so we have to take out from the child std in and std out, return them in some way from the worker process. So just return them from the worker process. Like, let me just write this down. So we have worker process. Yeah. So we can actually return from our worker process, take std in, take std out and stdr, and for logs stdr. And in this case, we would have we don't need actually none of these file descriptors inside our worker process, because our worker process is designed to solve only one purpose: to wait. So it's designed to wait. So worker process then can safely go to bed and sleep. Wait. Actually, wait bid system call. Like this. In a different thread. So this is thread 2. This is actually thread 1. Since we are executing everything, basically everything in parallel, we can also introduce thread 3 for the stdr, just to read like just read the data, because worker can send like any logs, any data during the execution. So like in between of when we send data to the stdin until we receive the data from the std worker can send basically everything, anything to the stdr. So we should have the ability to continuously read it and send to the our parent process stdr, just to redirect from one pipe to another to our parent process. So this would be connected to the parent stdr like this, and send data to the happy user. Nice looking head, but head should be yellow. Like this. So yeah, good, very good paintings. Okay, so let's now realize our plan. And I guess this plan will be broken by the reality of Rust. Okay, so now we have to introduce 3 new methods. First, stdin option child stdin and mute self, and we're going to so we actually don't need these things. We only need to have an access to our pipes. Child stdin take, like this. Option child stdin std process child stdin. Oh, we still use Tokyo. Yeah. Thank you, Tokyo. Bye bye at the moment. We'll return to you back very soon. finished exited. Actually, like this. So okay, -1 async function. So minus second one, and now we're going to let's use unwrap at the moment. So actually since we are prototyping, we don't need to actually follow this super follow about error, checking the errors here. Actually unneeded return statement, clip here. Yeah, so I did like this. Why you like did lift return here? Okay, we have everything fixed here. We have our updated execute function, and we have our 3 stdin, stdout, and stdr, which are like take. And we have our wait function. Let me now check. Okay. What you doing? Okay. std thread spawn. Okay, so let me do like this, just to I don't want to delete this part of the code. So we don't need a join handle, because join handle will actually stop us on, like, if we are going to use like this, let handle, for example, and then use a construction like this, handle join, and on this at this moment we'll going to block, because the process will block here until it exited from this wait for system call or wait bid. And now, okay, so we don't need this handle. Yeah, and so we should use a move here. Yeah, and if we use move here, yeah, so data is data here is so actually, yeah, we've got a little problem, but I guess I know how to resolve it. So we actually have data, our worker process, and data exec here, which are like moved into this thread. So data is moved to this thread and used here. So we can do this. But according to our plan, oh, whoa. What are you why are you compiled? Oh, async fn. What? Yeah. So. Oh, this is, yeah. Crates and SDK. Why are you compiled? Okay. Okay, so since this is inside the test, we can only see the error when we run correct test. Okay, so we expected to have this. So, okay, keep calm. We expected to have this error. And now we need to, according to our plan, extract. So wait can be used on the data. But actually we need to use our stdin, stdout, and stdr here differently. And let's try to do this. Let mutable stdr is equal to data stdr. Let mute stdout is equal to data stdout. and let mute std in is data std in. Okay, and now we're going to use it like this, exec, and we're going to pass here. So we executing on std in, yeah, and std in, which is mute child std in, like this. Sorry, typo. Okay, so mismatch types found, mute not oh yeah. So now we are going to use this send on the std in, like this. Why are you arguing this? Expected struct child std found. Why you expected something? No method sent. So you used to do from the Tokyo futures. What is this? Everything looks fine. Why you can't? No method named sent. Oh. Std out. Am I right? No, std out we can receive, read, yeah. So std in. Why am I so stupid? Std in. Might be so we should give a different name. Full bar. Like perfect. Oh, yeah. Exactly. So send is the method of, yeah. Actually send is a method which can be found on our Gorich library. This one. Yeah, this one. So, the next thing, I guess, which we can use here, we can actually construct our pipes here, not with the child like this, but path here our actual descriptors which we get from the worker. Oh my god, we did a so big mess. So this is basically because we're using, like, we should use std in right, you know, and like this, and mute frame and wrap like this. But we can do this because frame actually should be like this, bytes, but we also can do like this because this inside our Gorich. How we write all, yeah, write all, and how we send it, yeah, frame bytes like this. Okay, and now instead of using data exec here, we are going to use, oh yeah, we can't use data actually. Like, let's try data exec p and std in unwrap. Yeah, we can do this. We also should use like take. Expected child std. Unwrap, yeah. Yeah, and since we are using the same data here, okay, so we can use like entirely, like completely different data structure here. So we can use So in this case, what are going to do our worker? What is going to do this shit? Actually, because in case of Rust, we dividing at the moment and in three parts, like pipes, actual pipes, which implement our Gorage protocol, worker, and we getting out std in, std out, and stdr from out of the worker, and trying to assign it to a third one structure. Like I think it's not right. We should not do like this. Rust. 8 years, most loved language. Actually, it's awesome that I have to solve these architecture like tasks, you know. This is because when you start thinking about all of these concepts, I guess, so just my personal opinion, when you start thinking about all of this, how it actually boring works, then you start it definitely involve on the other languages you are working for. For example, I'm working also with Go a lot, and this definitely will have some I don't know, influence to the Go, how I write Go code, but not vice versa, because you can't write Rust code like Go code. We proved this several times. So, but vice versa, you can do this actually. So we don't have take, for example, in Go, for sure. We don't have anything so that can, yeah, we can copy like some kind of dereference the pointer, copy the data and nil the pointer, but this won't be the equal of the take, I guess, because it's too. Oh, fix me. Too much operations, I guess. Okay. So I don't want to move this abstraction out of the worker, yeah? I mean pipes. But we can move all operation with the process to the like a third structure. Like I don't know, we can move it to, so we can have pipes as a separate structure, not inside the worker, because if it's inside the worker, we are going to still use this construction. So we still use data. We can't use data because we are moved the data here. So data actually is here. So done. So we can't use it after this line. So after this one. No data. Actually after this line, but yeah, you know. So let's like split it as a separate process. We can't use the data like after this. And if we try to use anything, basically anything that returns to us a mutable reference, we can, I think, use, for example, kill data. Let me just check, because this is like this. No, still, yeah, both references, mutable and immutable. Yeah, so sorry guys, we can't use at all data after no data usage. Got here like in Linux kernel, you know, if you see like big panic trace, it's like cut here line, like they expected I print this screen and like cut it and send them by mail. I don't know. Okay, so this is a problem, and we have to design our application in a different way in Rust. to bypass this limitation and design everything correctly, I guess, in the Rust terms, we definitely have to use a different structure. Or we might, for example, return some executor from this exec function. Call it like before we start this thread, like on this line, for example. But let me check if we can use std, for example. Std unwrap write all. Let mute foo, which is vector, and foo. No. Oh. Std is moved. Yeah. It's moved. Oh, we have to call no, it's already called take. Std unwrap. So our plan, as expected, our plan crashed as expected. So our plane crashed. So actually our super beautiful and nice looking plane with a guy and yellow hat actually crashed, because we can't use stdr, stdout, stdin outside of the process. Outside basically here, because we called them from this data. Okay, let's use our famous approach called let's look at the others repositories. Like we did not so long time ago. What search term we used on like previously? I guess we used this one, command new. Language. Okay. So this is also a nice thing that you can search. No, not TypeScript. I'm sorry. Rust. Yeah, and this is repositories. I don't know what was commits. Might be. I guess they should be sorted. Oh no, they are not sorted. Oh, it's Java. Yeah, actually. Command new. We missed, guess I missed the repository of this super professional guy who wrote Bitof was bottom for a sec. Do you mean in this search? Oh, this one. Bitop tracked Bitop. Nice. Okay. Bitop is actually I just take like, this is just for like prettify my stream, so I don't use it in real life, only to track For example, when I test something in Go or benchmarking, so in this case I track this CPU, but actually no. GitHub, what is this? What is this? This is Microsoft influence on you? Why? GitHub status. So recently, oh yeah, nice. Nice, right on the stream. Microsoft doing its normal thing, yeah. Just like buy and kill, like. Actually, I don't think Windows is a bad operating system actually. So I have, for example, I have to buy, I was forced to buy the whole new equipment to work on Linux. Especially, I have to very carefully choose the vendors to buy the equipment actually. So this is very hard to buy something which will work on Linux, especially microphone, like XLR station. And I have like the second microphone, the second XLR station, which I bought for Windows, and it's not working for Linux actually. Yeah. So I actually, but I think I think Visual Studio Code is a good thing, which Go XLR. So wait for a second. I actually have this thing, like Go XLR. This one is, like, as you may see, this is like real hardware. It's not a joke. And I can say you with the full responsibility that Go XLR will not work on Linux in any way, on any distro. I tried to run it on Arch Linux, my favorite, which I use now. Ubuntu, Fedora, like I guess, how I can pronounce this? And Devour OS and the Our OS. I don't know how to pronounce it. So, and I can say, yeah. So you can just send me this link to this repository. I tried everything, everything basically. I tried this repository. But as you may see, in this repository, I didn't looked at the bottom at the README, but I can say now that at the bottom they wrote, if it's working, basically faders should work, microphone basically should work, beeper should work, but mute will not work. Where is it? Basic functionality. All of the output should work, faders work, the beep works. Nothing works. So actually microphone didn't work. I see system chat music channels, but they are not working, and I can test beep button, so because I just can't hear nothing in my microphone. So yeah, okay, they can say anything basically, but you talk at the moment with the man who actually owns one of this equipment, and I tried to do this. So why I have to buy Audacity XLR station if this thing works? Ask this question, I tried to. So actually, Pulse Audio is dead. So yeah. So Pulse Audio actually is dead. So I don't know. All modern Linux distributions use pipewire for basically everything. You record the screen on Wayland audio. So we have a bridge called pipeware alsa. I'm sorry, pipeware pools to like systemd daemon to just make a bridge to like run between the pulse out and pipeware. But so yeah, you can try it. I don't know if you get it working on the Linux. It would fine for you, but unfortunately I have to buy this thing, Audacity, Audient. I'm sorry, Audient. Yeah, basically this one. No, not ID24, but ID14. Yeah, this one. This one. This works pretty good on Linux, so with zero configuration actually. And I now to buy something on a Linux, I have to go into Linux kernel sources, like put the name of this device into the search and see if there is drivers or like edit compatibility in Linux for this device actually. So, and basically Audient devices are present in the Linux kernel, so I was sure that Audient will work. But you don't need to buy this one because it's, I guess, $200. This would be enough actually. I just I wanted to buy this one and just like misclicked and bought the one with more inputs and outputs. So basically the difference is you have two microphone inputs and you can have not a mono sound like this with one microphone. You can get two microphones and get a stereo sound, you know. Yeah. Let me check. Where this link? I guess I don't know. So as you may see here, they got an update on like February 9. They also own GoXLR utility, so this one, yeah. I don't know, I tried to install it, but also every time I try to install it, so they my adventure finished like with bad results, you know. So this is however, this, you know, this is a third-party repository, third-party guys. I respect their work. This is so cool that someone just tried to make the device working. I don't know why TC Helicon just doesn't care about the users who works on Linux. So the other guys, like these heroes, have to reverse engineer their protocol because, you know, so at the beginning of yeah, I know they have a package, but so for the previous version it won't work. So this is super cool that some guys started to reverse engineer the protocol and tried to implement this device, but still this is third-party thing. And when these guys said like, okay, so I'm just bored to support this GoXLR utility, you immediately lose everything. Like you have to buy a device which is like in supported officially. Yeah, it doesn't even support macOS. So this is ridiculous nowadays. I think so. I don't know why they. I'll try it. I'll try, I guess, after the stream to install their GoXLR utility once more time. Go XLR. Let's do this now. Yes, Rust. Let's try to see if it builds. So I don't know. Actually, I have a Stream Deck, and Stream Deck have support for Linux. As you may see here, this utility called BitFocus Companion, and basically you can track and you can like control OBS, Spotify. So as you may see here, this is my small, I don't know, page layout, how you control the OBS. You can. I just I just stole these icons from the official account. So yeah, so Elgato doesn't support Linux at all. So none of their devices support Linux actually. So. But there are third-party company like this Bitfocus, and they have support of their protocol, and you can make it working. So basically, I have everything except like some kind of fancy GIFs on my like icons, and basically it works. So you can safely buy and safely buy this Stream Deck, and it will work on Linux. Definitely work. I don't know. So I asked them. I wrote an email to their official support with the question about their devices, and they said, we can't guarantee anything, so because we work only on Windows and Mac OS, so it's everything on your own, and something like this. It's like a usual tech support answer. I also asked this guy, so I don't need you to make to give guarantees to me that this thing runs. I just wanted to ask you, have you tried to run it on Linux, and how it behaves on Linux? Just so I just need to experience tech support. And they're like, oh, we can't provide this information to you because this is not officially supported. Yeah, GoXLR build. Yeah, so I'll try GoXLR and we'll see if it will work. That would be awesome, actually. Yeah, so because previous iteration of this GoXLR utility just won't work. And thank you for following and enjoy the stream, Round Dev. Yeah, so basically I have only this TC what is the name of this microphone? It's TC Helicon, also TC Helicon microphone. It fellow Thunderbird user, yeah. So I have a Firefox account. I have everything with Firefox, but they just as super dumb managers, super dumb, because spent millions. Let's see how Chrome developed by Google. On Windows, you can have this feature I can't remember from NVIDIA, when the image can be upscaled from the lower resolution in Chrome to the 4K, for example, and it looks awesome. This is the first. HDR. I have a HDR display, and I can't use HDR in Firefox. So you just can't convert me into Firefox because, since they doesn't support HDR, I just can't use the Firefox because HDR looks like different and looks just awesome. If you have videos in which support HDR in Chrome, it just looks awesome. Like colors so bright and so, I don't know, vibrant. Super cool, Hello, Copa. Yeah, so Firefox, managed by super stupid, by the brilliant team of the programmers, but a super dumb team of the managers, I guess. So they spent millions of the dollars of their budget to, I don't know, to what? To create another organization, now we support artificial intelligence. Mozilla, please stop. Previously I worked with a guy who worked as a DevOps in Mozilla, actually. this is I guess it was like 3 years ago in one company. So this guy came from the not from the Firefox, but I don't know the like department where this guy worked, but from the Mozilla I know this for sure. And he said me, yeah, so they have a super dump management team, unfortunately. And I guess nowadays, as you may see, market share desktop browsers. You know, it's like 7.1, like 6.8. They like Safari, Edge, even like, you know, shitty Edge is having like 10%, 11%. Opera, are you still alive? Actually, Opera. So yeah, I know the Chrome, I guess this I don't know how, where is the Brave actually? So I also want to see a Brave. So might be Brave somewhere in this dotted line. I don't know. Here, somewhere here. Or might be Brave somewhere here, like minus 10%. Yeah, basically everything is just skinned Chromium. So Chrome is skinned Chromium, Brave is skinned Chromium, Edge is skinned Chromium, yeah, skinned Chromium, and yeah. Yeah, I don't know. I actually don't know why they need a pocket. So why they need a pocket? So I used actually the pocket like 0 times. I used the pocket. I use actually in the Chrome we have where is this page? I guess it's on Windows. No. So the page with the like bookmarks, but they are like located somewhere here, like at the right side. So I don't know. So I guess they deleted them or what. So this was very useful. I can like save like a page and read it later. Ah, yeah, here, yeah. So just missed it. Yeah. So let's the holy war begins, you know. Yeah, so in this reading list, this is kind of super feature, I guess, because I can save like for example a videos or page here just to like read this later. It's like actually this is like a bookmarks, but bookmarks. So for the bookmarks, I don't want to actually save them. I want just to read them and you know, and like read and forget. So this is very useful, I guess. This is reading list. I know. So yeah, browser works actually. Okay, so how we are going to resolve our problems with Rust, with actually Rust team. So I remember you guys who doesn't know. No, this is the standard one. This is Linux. I can't have anything custom except my desktop environment, you know. So actually, what can I do? I can have might be some kind of I don't know, custom skin, but why? I'm in Linux. I have Tealing Windows environment. What? Oh my god, it's super cool, super you know, I don't know how to say this, like super modern like layout. Super shiny. It's not minimalistic. So look at your cursor. It's like some purple bulb. or what is purple drop? I guess. Oh, it's on Windows. Oh yeah, you're on Windows. Yeah, it's fine. WSL is actually good on Windows nowadays, and they also I heard rumors about Windows 12. Windows 12, and so they have definitely some good things on Windows. For example, I can remove the background. I don't like this square camera thing. So I can remove basically everything which is like located here and have a good background. Yeah. So yeah, might be it's yeah. I don't know. It's look pretty actually. Like I like this purple. I don't. But actually, I can see your pocket, or this is the pocket. Yeah, this is fine. I'm not blaming people for using Windows. Actually, I was on Windows very long time. Tree style tab. Oh yeah. I remember this extension. Yeah. I like on Windows that basically everything works. So this I like in Windows. Basically everything of my equipment works. Without any problems. I can install any driver. I can install driver from Stream Deck. Like basically WSL2 works. I have, if you want, I have a tutorial. This one. It's so how to install Arch Linux on Windows actually. So into WSL without this fancy modern things like Arch WSL. So because they are from some Chinese developers, I guess. So without all of this kind of shit, I actually I don't like when someone trying to make Arch, like install Arch with one click. So you have to feel pain when you're trying to install Arch Linux. And basically this is tutorial how to, slightly feel pain, but with according to the tutorial, like controlled pain, I guess. So yeah, and when you finish this tutorial, you'll have basically working Arch Linux in your WSL. Yeah. What is WinFetch? Oh, if Jolly Jean on a stream now, you'll actually got a friend. Because Hyperland was like WinFetch, like NeoFetch, but for Windows. I didn't expect that someone can create a like fetch thing on Windows. I tried to buy 7900 XTX AMD video card. So I bought actually this video card. Yeah, so I don't know what is NeoFetch. Do I have it? No, I don't have it. Boom. Basically, I tried to use Wayland and Hyperland, but my experience was pretty bad with Hyperland. I didn't get working my icons in a tray. I didn't get working OBS properly, so because I'm compiling it from the sources, and basically it's very hard to make it working on Wayland, especially with AMD drivers, because with AMD you have to use Advanced Media Framework, and Advanced Media Framework is a like just piece of shit, because 7900 XTX with 24 gigs of RAM can't run my stream in 4K. It's just like can't do this. It's just working in 60 FPS, and it's just encoding it in, I don't know, like 35 FPS. Yeah, i3 is actually a super good until in Windows environment. I enjoyed it like a lot, because it's like you have everything on their places. You have like your windows aligned properly, so you don't have these big headers of your windows, for example, like you have in GNOME or KDE or any other like non-thinning window manager. So now I have like teeny and small and basically informative things on the top of my like window manager. I can like basically form anything I want. I don't think you should do this nowadays, because Wayland is a shit number 2. It's like a good fairy tale about the Wayland. Wayland is everywhere, so everyone tries to have a Wayland on their PC. Actually, so if you try to run Wayland, for example, if you have 2 screens with a different resolution, you can say bye-bye to Wayland, because you would have a different DPI and your fonts will be super blurry, like washed out like fonts. Yeah, so it's not a problem, but actually I tried to use Wayland many times, and the problem with the Wayland is that you have basically a problem with fonts. If you have if you have an IDE or you have a different type of Windows, so X-Wayland and Wayland native Windows. If you have, for example, I want to have 1.5 scale on a Wayland, you know. So I don't see any difference. Actually, I don't see any difference. So with Wayland and non-Wayland. X11 is a good, nice protocol. I have everything compiled. I can basically compile everything for myself. I basically doing like this. I compile in OBS, all my software compiled from the sources. So I'm doing this with X11 with easy. Actually, Microsoft documentation is good nowadays. But yeah, but I expect X11 documentation is much worse than current Microsoft documentation. Yeah, I know that for sure X11 should die as a protocol, because it was designed, you know, a very long time ago, and the X11 protocol have a lot of things, for example, rendering windows on so I don't know actually the internals of the X11, but you can just read in Wikipedia about these differences. And I like very much that Wayland Windows rendering directly on GPU instead of, I guess, X11 rendered with a compositor. I don't know actually, so I can be wrong here, but I don't see any improvements in latency of the Windows so I bought this 7900 video card just specifically to try Wayland, because now I have 3080 Ti NVIDIA, and this was a lot of pain to configure actual AMD graphic cards. So because if you just a developer, so you are not trying to stream your like developer's day, for example, as I do, so this is fine. But when you start to stream something, you have to install AMF framework, you have to install proprietary drivers from AMD, because AMF works, AMF is the encoder for the AMD, works only with the proprietary drivers. Or you have to compile a special version of OBS called OBS Studio AMF to have it working. So you have to do a lot of things just to make it working. Instead of the NVIDIA, so NVIDIA, I have to add only one, I'm sorry, etc. making it SPIO. So basically that's it. I have to add only this models for the NVIDIA, and it works. Even my laptop with I guess 1050 Ti can run my stream in 4K and 60 FPS. 1050 Ti. It's like how many years ago? 1050 Ti mobile release date. Yeah, so as you may see here, January 2017. It's like 6 years ago, and it can run my stream in 4K. And when someone asks me about the AMD, I say, okay, it's fine, but I tried it on Windows. No. So you're definitely wrong. So I tried to run AMD driver on Windows as well, and it doesn't support an HDR on Windows. Because as I said before, I have an HDR display, and every time I reboot my PC, I have to configure HDR from the beginning, because their driver drops the configuration every time I like restart the Windows. AMD drivers suck completely, like 10 times, I guess. NVIDIA drivers at the moment is pretty good. So I know that some, for example, Sway, the politics of Sway, like we won't use proprietary drivers. But what is the reason actually? So why? Okay, they have closed sources, but a lot of things have closed sources. And if we start arguing of everything that have closed sources, you just remove everything from the Sway. NVIDIA support Linux very well nowadays. Very well. So I'm very much so I have less problems with NVIDIA and streams and everything related to NVIDIA than with AMD. Actually, yeah, you can like use Wayland with AMD, but you know, Wayland, for the Wayland, I don't know what is the reason. So you just, okay, you can like just say, okay, I have a Wayland for Wayland. What is the purpose? So to run Windows a little bit smoother. Okay, so I don't know. So I don't see any reasons. Pipeware also works not very good with actual Wayland. I also tried to do so. I have all of this. I had previously all of this experience. I had 6900 XT video card. I sold it and bought my 3080 Ti. Then I had 79, so this is a super new video card, 7900 XTX, and also I had exactly the same problems after 2 years, I guess. Yeah, after 2 years. And yeah, everyone trying to say that, okay, NVIDIA is bad on Linux, NVIDIA, but actually, yeah, NVIDIA sucks on Wayland, for sure, at the moment. NVIDIA sucks on, I guess, VA API support. And while it's, and because of it sucks on VI API support, NVIDIA sucks on supporting Discord, for example, and Chromium Stack, which, so applications actually which use VI API to run on Wayland. So you can't run nowadays Wayland, NVIDIA, and Discord, for example, without tuning Discord distribution or compiling special version of Discord called, I guess, Discord with a super new electron inside it. yeah, so you can bypass, but this is problem only with the Discord. Only one. I have only one problem with Wayland on NVIDIA. Only one. This is Discord. And basically, I tried to also run streams on the Wayland, and they crashed on NVIDIA. Yeah, I also hate Electron a little bit, but so basically everything nowadays running inside the Electron, everyone tried to do this. I don't think that so this is only my experience, so you definitely might get a different one, and you might have a super smooth and super good experience with AMD, but I will not buy an AMD, never. That's it. So AMD closed for me. CPU is closed because I had previously also 5950 5950, I guess that's it, 5950 CPU. It also so hot. I don't know. It's like like atomic station. I don't know. It's like I can turn off my heaters in my room, so and only leave my PC working with AMD. And also, which is more important thing, as you own Windows at the moment. On Windows, you can't use inside WSL AMD drivers. So if you would have a GPU and AMD GPU, yeah, 5950X, yeah. I sold everything related to AMD. I sold the whole PC. So I never buy so anything related to AMD. So only Intel and only NVIDIA. So that's it. So this is my story, like. And basically, so why is AMD trash, in my opinion? For sure, I'm sorry if I hurt you, so it's just my personal opinion. So I'm sorry if I hurt anyone in the chat, but with my opinion of AMD products, for sure it's only my experience. But for example, if you wanted to use WSL2 and AMD video card, you won't be able to use it inside WSL2. Yeah, preference is cool. So basically, if you have an NVIDIA video card, you'll be able to use it also inside your WSL2 and inside Linux, actual Linux distribution. So you would be able to use this as a host GPU. So basically, any operation that's available for me on like bare metal Linux will be available for you on WSL2. And nowadays they released Microsoft DirectX 12 WSL2. Yeah, so nowadays they announced that it's a super cool feature with Mesa 3D and DirectX 12. And as you may see here, this is just running inside Linux. Someone started this video out in the Linux, and it's working on the Windows. And you can do this with GStreamer, and you can do this with actual NVIDIA card. AMD doesn't care about this at all, so AMD drivers are not available inside actual WSL. AMD WSL2 support, so they have ticket, I guess, for a few years at the moment. Where's the AMD GPU? Closed. So like 3 years ago. Yeah. And this one, the recent one. And Rockum is like also pretty bad software, because So I think they produce a very good video cards, like in terms of performance, I guess. So they can perform very well, but in terms of support, they support very, very poor. You know. I'm sorry, microphone. So okay. this is like small talk. Let's continue our pain and let's cry on Rust. So our initial plan was destroyed. So that was a good plan with a good man, but since we can't use stdr, stdout and stdin outside, even outside of the of our worker process, we have to deal somehow with it. And let me try to find, let me close all of this. This. Oh, they still have problems. So it's like too often, I guess. They had the problems, I guess, a few days ago, big problems. So everything was red, and now they have problems. I guess this is because they moved to Azure, to the Azure. Let me. Okay. We don't need this. Yeah, and we tried to search the thing, and okay. I guess this repository code somehow had the name like Ruby or some kind of. Rust VM. Oh, HHVM from the Facebook. Rustdeck, Rustdeck. Wasmer. Even Visual Studio Code. Oh, Visual Studio Code also have. Oh, I guess they have LSP. Oh, yeah, for the Rust. OpenTelemetry, like immediately Microsoft OpenTelemetry. So I guess I sorted all of these repositories by like Rudy. Yeah, I guess this one. Yeah, this is the one. Yeah, this is the one we use. I remember the name of the repository. So the name is Buildbox Ruby. So, and here we can see an approach from like more experienced Rust developers how to deal with how to read from different processes. And I found an approach. Let me open this. And also I do love this thing that you can open Visual Studio Code editor on every repository and use it like in a browser. So it's super cool, I guess. Env commands. Okay, so now I guess they have they should have how they use file descriptors. So and wait on the different threads. I guess it was in this repository. So they had this approach. Because this is like, I don't know, this is something that everyone should do when they deal with the process and with the commands. Because on every command you should wait or check the exit status or I don't know. So, and every command which started should be waited in a different thread. because if it's not waited on different thread, you just block on the wait, and you can't use anything basically because you are blocked. And output and write streams. Oh, this is stream. This is let me try to search this in the history. GitHub. And that was yesterday, 28th of March. And search. Yeah, this is definitely this repository. Yeah, this is the same repository. Env command. Yeah, so this is a command, new self-base. This is a command from args for the command. And this is the output self command. And capture std out and stdr. Yeah, this is kind of easy also to achieve, but I need a little bit more complicated stuff. So I'm pretty sure that we looked at this repository yesterday, but I can't find the code. Might be that was some commit. Oh my god, guys. So I'm trying to find a way how to actually split a process into separate parts. So how to split std out, stdr, and std in from the child, and read and wait child. While we're waiting on the child, we can just use stdr, std in, and std out. This was, I'm sure, this was this repository. env comments where they also have the env comments. Oh, let's search like this. Thread spawn. Oh, they don't have. This is not correct repository, I guess. So because in this repository they had, yeah. So they had thread started in a different threads, std and std. Let's try to find not thread but actually .wait. So where they waiting for the process, and unfortunately they are not waiting for the process execution. Yeah, so I was wrong. This is not the correct one. So command new and language Rust. Okay, let me search over the commands. Tokyo. Yeah, so this approach also in async function, also, yeah, we can use Tokyo approach and use, this command from Tokyo, which is async actually, and we can use this spawn, expect, and status, and use an await in async function. But actually, we will be blocked on this line. But so we have to invent something different. So this will not work like in Go. So let me just show you how it works in Go, and let's review this together. So in Go, this works pretty easy actually. So we have this exec function. This is a lot of like functionality basically related to the setting the finite state machine and the worker in a proper state, like execute the payload and etc. etc. So it actually doesn't matter for us. Basically what we are doing, so on this worker we have an exec function and we have a relay. Relay is our pipes which implemented in Gorich in Rust, and pipes are attached to this attach relay function. So actually we are attaching this relay and we can communicate basically with every relay we want. For example, we can communicate via the pipes, we can communicate via Unix sockets, TCP sockets, yeah, and that's it. 3 ways to communicate. And all of them implement the same interface, so basically you can like just vary in implementation, but in terms of worker is capable to run on anything of this. And then we are starting our process. Start function is actually asynchronous, so they use a coroutine on the start. Yeah, so like coroutines, and so there are a lot of logic, but trust me, I digged into this runtime. So this basically started in a different thread, so it's non-blocking actually. And this is the first problem. Since this is started on a Go routine, this is a mutable reference. After this point, in terms of Rust, we are not able to use this function wait. In terms of Go, so this vcmd, so these two things, let me just make font a little bit bigger. So we are not able to use this vkmd and this vkmd. They are both holds a mutable reference because they both can contain a mutable process inside them. So this one can set, for example, exit status for wait, but this one can set, for example, error state. And if we called start and wait very fast, this will lead us to data race for sure in Go. But in Go, I know this, and I don't care about this data race, because if I would have a data race here, if it will definitely lead to the error in when I try to check this process. I'm always checking this process after some time after it started. So and when I check this process and it will be in inconsistent state, I'll just, okay, fine, kill, died. So, and please give me the new one. This is super rare case when you try to, when the you start worker and immediately get an wait condition and it exited from the wait. And I guess they have a comment about this. Maybe on the wait. No, they don't have any comments, but actually Tokyo Library have a comment on their wait function that to avoid a data race, they close stdin just to make sure that no one waiting on it, and they can safely use this. They just drop in it and with the drop function, and they can safely use safely wait on this process. But so basically, this is very easy to accept this risk in Go, and I know what I'm doing here. So it like in C++, you can easily accept some kind of risk. But in Rust, you can't do this. Rust doesn't allow you to accept the risk. So everything should be pretty much safe. And basically, here, this wait function runs in a different Go routine. And in terms of Go, nothing is moved inside this wait function. So this is not like we are having in Rust, like this one. We have to move the resource inside this thread. And so we can't use it outside of this thread anymore. So we can't use anything basically related to the data outside of this thread until we finish this thread, like join and join handle, let handle, and handle join unwrap, like this. And at this point, I expect that we would have the ability. We should have two arguments. Let me to foo. So you don't need any more here. So if we let me remove this. So basically, this is possible to use after this construction, because after this construction, everything freed up in terms of Rust. But in terms of Go, so we have to run this function in a separate Go routine, and we accept it. We accept this risk on us, in Rust, we have to invent something different. We can't just copy this approach used in Go. So basically, Rust forces us to think and to invent something different. And in this case, what we can do in terms of Rust, we can start the process and move, take in terms of Rust, or move outside of this command 3 file descriptors: stdin, stdout, and stdr. So this was our initial plan. And so we can't use this. I guess we should move out the child. Oh no, we can't move out the child. We can move out the child and 3 file descriptors and then use wait on a child like this. I guess so. This should be possible. So this is like we are fighting with Rust. So do we have an update? Oh, C-line was updated. So let's see what's new. Debugger update. I like debugger updates. VCPKG. So VCPKG, this is a Microsoft. Microsoft tried to write a package manager for the C++. So VCPKG. This is a nice software, piece of software, because I also used it previously when I use C++, and I even create a few pull requests to it. So this is kind of good software. Yeah. So at this moment. CLD-based indexer. This is also nice. Yeah, I'm waiting for this new theme, but I don't want to use because it's like too thick and too big. All of these borders too big for me, and they, I guess, introduced some kind of smaller compact mode. Yeah, compact mode. We'll also try this. Disassembly on demand. Nice. What is? Do we have something related to Rust? We should have. QML, profile coverage, terminal in the output console, so we can play in games in the terminal. So useful. So yeah, this is definitely worth my money. So to play tiny Tetris. CMake enhancement, new UI, compact mode. Yeah, so I waiting for this new UI. New dark theme. Yeah, also super cool. Yeah, I definitely worth all of my money. So new theme. So don't use this. Markdown. So yeah, Rust plugin update. So this is it about Rust. Oh, this is it. Not so much. But yeah, thank you guys from the JetBrains. You did a great work. I guess it started much faster. Oh, they now created this super cool page. What's new? So I can't remember that this page was in previous releases. Now I have to update all of my plugins. Yeah, as usual, we have a lot of plugins which is not supported by current. By current version of the IDE. Yeah, this new IDE starts definitely super fast. It's like much faster than previous one. Okay, guys, so I'm ready to do this. Enable the new UI. Okay, background tasks. I'll wait for you. Sorry, background tasks. Too long. Please not be ugly. Oh my god. You see this? It's like half of my screen of this super, I don't know, this is like a sausages. Like German sausages, super big. Just full. Oh my god, where is the compact mode? They promised me compact mode. Where are they? Where is this mode? Slightly better, but why do I need this? Why do I need this at the bottom of my, at the top of my IDE? Why do I need this big button? So I guess they forced me to use a standard. Oh my god, it's so big. It's like I'm completely blind, and they meet the new UI. Compact. Oh, finish setup. Oh, they have this nice setup bar. I would say that the new dark theme is good, so I like it. This is something. This is not Groovebox. Groovebox unfortunately doesn't support it by Go. Doesn't support Groovebox. Everything is white in Groovebox. My favorite theme, but so guys from JetBrain, if you'll see my poor streams, please answer the questions. Why? So I can fit 3 RoadRunner RS here. So right at the top of this label and at the bottom. Why to waste so much space here? And compare with the old one. So definitely, so this is definitely shit. I don't want to use it. And compare this with the old one. Huh? Huh? You see? So it's like, it's super cool. So everything's that I need. So I don't need to have these so big buttons, like for blind. I expected a lot of the improvements from this new theme, but unfortunately they failed. And I guess this new dark theme also supported only in the new UI. Okay, so let's return to the origins. Something changed. I guess it. So something definitely changed with the fonts. Okay, so. Yeah, I think you're right, Yoma. So because this is so ugly to see on a desktop. This so big buttons. So I don't know. They expect me just to code like in this, like in this space. Like I have everything in the buttons around, and only this small window for the code. And this because I want to switch to NeoVim. Let's see. Spiral, not the spiral, I'm sorry. Yeah, spiral. RoadRunner RS. No, this is in my under my. Yeah. See? It's much more pleasant. So you don't have anything. Basically everything is super cool. All of these things. Why not love Vim? Why not to love Vim? Having so cool UI. And also have an errors, as you may see here. So STD in mood due to this method call. Okay. Oh, stop. Run screen. Okay, so we have to. Okay, we have to rework everything related to our execution and related to our function. So we don't need this one. Okay, so let's try to design. So we definitely can't use this like in Go. Definitely. So this doesn't work. Any abstraction used in Go doesn't work in Rust. We can't use worker actually, so it should be called different. It shouldn't be a worker anymore. Because basically we can't use std in and std out and stdr inside the worker. Or we should what if we no, still no, we should use this so I don't know how to interesting to scroll. So we also, guys who don't know, we're also working on this Vim Adventures. So this is exercises to switch to Vim actually. And we passed already a lot, like restore game. We passed 8 levels actually on this game, and I guess at the moment, yeah, we are trying to return to the origins here. So, and after we pass all of these levels, I'm starting like my complete transition to a Vim. So I have some kind of pre-configured here, some kind of some small configuration, but we are going to design everything from the scratch. So who wants to join me in this in this Vim adventure in real life? So please join. We are going to cry together at the beginning, and then when you like start coding Vim actually. So when there was these good old times when you was in the office and you leave your PC unblocked and go to have a water or to have a cup of coffee, and like your friends like and trying to print something I one time I deleted Go from the one guy in our team right before the presentation. That was so fun how he tried to what happened to his PC, and he got the lesson. Never leave your laptop open and not locked when you go to have a coffee or something, or go to the toilet, or basically in any place out from your laptop. And that was a funny story. So everything was all right, so nothing bad happened, but this was like I deleted Go. And when you work in Vim, no one can hurt you, because no one knows how to exit Vim to hurt your PC actually. So it can do like this. Okay, this guy's too smart. I can't do anything to his laptop. This is the only purpose we learn in Vim. Yeah. So and if seriously, actually, I don't want to use my JetBrains anymore because they went in a like super bad direction nowadays. So I pay like $200 for the toolbox for the all IDs because we are using with a friend. So I'm using Goland, Sea Lion, and IntelliJ IDEA, and my friend uses actually PHP Storm and something from the web. So just I don't want to pay $200 for a big theme. Yeah. Okay, guys. So I guess this is it for today. So I am going to think a little bit about the new design, and since our plan, as usual, was destroyed by Rust reality, tomorrow we are going to create a super robust new plan, which will also be destroyed by Rust reality. But we are going to try. We should try and fail until we reach a success and until we will be super proficient in Rust. So, and we are going to create new plan to actually somehow update our actual worker and use different approaches. And I'll try to find this repository with this super cool approach to read from a different in different threads from like stdin's data to there. And we are going to do this tomorrow. Please stay tuned and thank you for being here with me. And as usual, see you tomorrow. Have a good evening and bye bye, guys. See you.